All right, welcome to Math with Mr. Strands. This is Matthew C. Zeta book, lesson 2. Okay, talking about expanded notation, exponents, things like that. So if we look at the first options up here, I'm going to write in red today. Label each diagram as a power of 10. The first ones have been done for you. So if we look at this first box, we can see it's 10 is the base, 10 is the height, and on the top you got 10. So you got 10 to the third power there. Okay, if we look at the second one, on the side we got 10, and on the top we got 10. So this is 10 to the second power, otherwise known as 10 squared. It is called squared because it makes a square. Okay, down here, this tall skinny one, we got 10, right, to the first power, right? It's only going up 10 on that side. It's gonna be 10 to the first power. And then on this one, the tiny little one, we don't have any 10s. So 10 to the 0 power. We know anything to the 0 power is going to be 1. For instance, if we zoom really close into this and we do base, the length times the width on this, 1 times 1, we know is going to be 1. 10 to the 0 power is 1. Okay, this one says fill in the blanks. So this is just wanting us to write out what each number is raised to that power. So 10 to the 6th power, it's going to be 10 times 10 times 10 times 10 times 10 times 10. They don't necessarily want you to solve it yet. They just want you to practice writing it out so you can see how many there are. Okay, so number 3, 10 to the first power, is just going to be 10. Number 4, 10 to the 4th power, we got 10 times 10 times 10 times 10. We will solve them in later lessons. Okay, 10 to the 5th power, we got 10 times 10 times 10 times 10 times 10. Okay, the 6th power, they want us to put the exponent in now. So if we look, we have 1, 2, 3, 4 zeros there after for 10,000, right? Which means it's going to be 10 to the 4th power. Okay, for number 7, how many zeros do we have? We have 6 zeros. So that's going to be 10 to the 6th power. Number 8, we only have 1 zero. So it's going to be to the 1st power. And then number 9, we have 2 zeros. So it's going to be the 2nd power. Okay, going on to the next page. Write the numbers in expanded notation and then in exponential notation. Okay, so if we look at number 10, it's been done for us. First, they write it in expanded and then exponential. So for number 11, we got 276. We're going to first write that in expanded notation, and then we're going to write that in exponential notation. Okay, for 276, we're going to do 2 times 100, which would give us the 200, okay, plus 7 times 10, which would give us 270, plus 6 times 1. Right? So that is 276. If we want to write that in exponential notation, we're going to have 2 times 10 to the 2nd power, which represents 200, plus 7 times 10 to the 1st power, which represents 70, plus 6 times 10 to the 0 power, which represents the number 6. Okay, so you would have 276. Okay, next one, we got 1,409. So we're going to have 1, right, times 1,000, plus 4 times 100, plus 9 times 10. Okay, you don't have to put the 0 in there because it does not it represents the tens place, but there's no number that you need to write in there. Okay, exponential notation, we're going to have 1 times 10 to the 3rd power, which represents 1,000, plus 4 times 10 to the 2nd power, which represents the 400, plus 9 times 10 to the 0 power, which represents the 9, right? The ones place, which is 9. Okay, number 13, 31,500. We got 3 times 10,000, which represents the 30,000, plus 1 times 1,000, plus 5 times 100. Okay, exponential notation, we're going to have 3 times 10 to the 4th power plus 1 times 10 to the 3rd power plus 5 times 10 to the 2nd power. Okay, if you really wanted to get technical with it, you could continue to put in your zeros. This would be 0 times 10 to the 1st power plus 0 times 10 to the 0 power. Okay, now we're going to write in decimal notation. What decimal notation means is basically just writing out the number, the whole number that this expanded form represents. So if we have 8 times 1,000, we know we're going to start with a number starting with 8,000. 4 times 100 is 400, so 8,400. If we look here, 3 times 1 is 3, so there must be nothing in the tens place. Okay, so 8,403. Okay, number 15, we got 7 times 10,000, which is going to give us 70,000. And then we got 6 times 10, which is 60. So there's nothing in the hundreds place. There's going to be 60 in the tens place, and then nothing in the ones place. Okay, number 16, 4 times 10 to the 3rd, which is going to be 4,000. Okay, 9 times 10 to the 2nd, which is 900. 6 times 10 to the 1st, which is 60. And then 2 times 10 to the 0, which is 2. Okay, number 17, 3 times 10 to the 3rd, which is 3,000. 5 times 10 to the 2nd, which is 500. 3 times 10 to the 1st, which is 30, and there's nothing in the ones place. And then the last one, 5 times 10 to the 4th, that's going to represent 50,000. In fact, I need to erase that 0. Okay, 50,000. 2 times 10 to the 3rd is going to be 52,000. So we got 52,000. 1 times 10 to the 2nd is going to be 174. Okay, so that is expanded notation, decimal notation, and exponential notation.